Hello everyone, this is Jason Sikes, aka the Tech Rancher. This is homework lesson number 11 from the course Raspberry Pi Pico W, lesson number 11, controlling a dimmer LED with a potentiometer. And in lesson number 11, Paul shows his solution for lesson number 10, which is the same definition or same description as this one, but he shows it, and he also shows us something really interesting. He shows us that we should be able to take our value. Bear with me here. I'm trying to change camera's view. Oh, hi! You guys actually get to see me here. Hello. What he had done is he took the value and exponentialized it. Let me start out first with what I did on lesson number 10. Be able to help explain better what he did in lesson number 11. In lesson number 10, what I did is I took the data that we got from the potentiometer, which is an ADC, analog to digital conversion, and I put that data straight into the PWM, pulse width modulator, because they are still the same data format. 16-bit on both sides. I just figured keep it simple, smarty. So we just keep it the same and not have to do any math. But Paul, in a comment, challenged me. He said that the LED does not really change very much, meaning towards the luminance towards the end of the rotation of our potentiometer, and it started to make me wonder why. So. Paul, I didn't watch a lesson number 11 yet after he gave me that comment, but I was starting wondering why is that? So then I cracked open lesson number 11, watched it multiple times, and even opened up the link of Khan Academy, exponential growth. If you're interested, the link's going to be in the description for that too. But I have to say, after 25 years of not really using my brain for hard math, or actually really any kind of math, you kind of tend to forget a lot of the things that you learned in high school, of like how to do stuff like this. So a linear slope is what Paul said I was doing, not the best solution. As you can see, the graph here that I have, which graph represents y equals x. And it's because I'm taking the same data value from the analog to digital conversion from the potentiometer and sending it straight into the pulse width modulator to the LED, and it's the same 16 bits, same. So for every movement of x, it's the same movement of y. And if we go here and look what this looks like, if we run it. Let me go here. You can see it. You can't see what I'm doing here. Let me convert that here. Let's see. Start this. With every movement of x is the same movement of y. So every movement of turning of the knob equals the same amount sent into the LED. I thought, man, this is a great solution. But as I get closer and closer to maxing out, as you can see the values down here being rotated, scrolling through. Let me see if I can actually increase this. If it would let me. There we go. As I scroll, you can see the value increasing. As I scroll closer and closer to being full max, the luminance doesn't look like it's changing to our eyes. That's because we're using x equals y. In lesson number 11, Paul uses a perfect example of using the exponential value. Let's go back to the graph here and show you why. Let me move to a different camera. Oops, wrong one. Here we go, and let's go back up to the graph. Whoa, what's going on? If we go here to our graph, wow. When you really change things, don't I? Scroll back down here a little bit. This up here, y equals 2 to the power of x, is what Paul was teaching us in chapter 11. And once again, 25 years of doing really hard math, really can't remember what that really means. Khan Academy does a really good job of explaining that, but so did Paul, but I wasn't grasping it very well. Watching the video with Khan Academy helped me be able to understand it a little bit more. So let me try to explain what I learned to you. Let's look up here real quick of what we did math-wise. Well, that's not going to show us very much. Let me do something else here. Let me show you a little bit of my notes that I did. And these notes probably look really small to you. I wonder if I can increase my view of this. View, zoom. Let's see if we can zoom in 150. There we go. Now you can probably read that. Okay, what we're going to start out with is we have to start out the same thing as we do with any kind of slope. We got to come up with two points. Well, we know if we have the potentiometer all the way to 0, that's going to also be 0 in our pulse width modulator for our LED. So that's our first point. 0, 0. Our second point that we're going to need is when we turn the potentiometer to full max, it's going to read 65,535. We want that to tell the pulse width modulator that is the same value, but we want it to do it in a power form. Well, we know 16 to the power 2 equals 65,535, or 36 actually, or 35 if you count 0. So that's why Paul was saying that's what we need to do. X to the power of, or x is the power of, to the power of 2, or 2 to the power of x. Sorry, let me get that correct. So now we have our second point because we know we want 16 out of our y value. So then we plot them. And if we go back here to pulling up our plot, and that's what we did. We're plotting 2 to the x. And if we go back, and I want to look at my notes here to kind of explain this a little bit more. So we take those 2 points, and we be able to get a line out of it. It's an exponential line, but we get a line out of it. Now we need to solve to be able to get anywhere on that slope. We want to be able to take the value anywhere off that slope and be able to take it to the pulse width modulator LED. So now we take the formula, point slope formula, which is well, first of all, to get to the slope, it's the formula of delta y over the delta x, the change in y over the change of x, or y2 minus y1 over x2 minus x1. Paul has showed that many times to us. By now, it's hopefully old hat. And same thing with the point slope. Paul has shown that to us too. It's y equals, or y minus y1 equals m times x minus x1. You can see here that I have it down as y equals our exponent value equaling 16 over 65,535. Is my math correct? Yep. Okay. Sorry. My brain went out. Times pot value, which is going to be x. Now we take that. We're going to put it into our code. Let's go over here and look at that. I still haven't got this down very well to go out to this. All right. Here we go. We'll go down here. There. Well, wait. Let me go up here to the top here and explain a little bit what I'm doing with this code. We're going to call in our library of a machine, and then we're going to call in the objects that we're going to use, or the classes that we're going to use. We're going to use pulse width modulator, PWM. We're going to use analog to digital conversion, ADC, and we're going to use pin. We're going to import time and the class sleep so we can be able to use those. You can see I already gave the value into the variable of dt, which is we're going to use for time, our sleep class. Now we're going to create our objects. my pot is ADC with pot in, which we have. Oh, I skipped it. Sorry. LED out. We're using pin GPIO pin 16. Pot in, which is GPIO pin 28. And then we go back down here and creating them. And this is pretty simple. You've already done all this with Paul. And then scroll down here, and I got my try and accept. While true is always true, as Paul always says. Then we're going to read our potentiometer and store it into the pot valve. Then we did our, I talked to you a little bit about what I did here. Then we're going to use that into our formula. Then you can see, there we go, we have exponential value, and that equals 16 over 65,535 times pot valve. And so now we store that into the exponent value. LED brightness is another variable that we're coming up with, and this is what we're going to use. We're going to take 2 to the power of exponent value. I went ahead and printed all of those out. I want to make sure they're correct. That's what you see down here. Well, this is actually the other one. This is what you see down here when we run it. And then the LED, we're going to call it an object, or pulse width modular object, and we're going to put the value of LED brightness. What we just done, the calculations that the math that has just been done will be in there. And we have a sleep. Let's go ahead and pull up that camera view so you can see. Move this mouse over here and get me out of the way, and let's run this. Okay, as you can see, the new values. I'm going to zoom in a little bit again so you can see this a little bit better. Okay, you can see the new values that we have. And let's start from turning the potentiometer far to the far left. Now you can see our value is really low and the LED is not illuminated. And as we slowly turn it, the LED is actually really small illuminating, but it's taking quite a bit of turning to get it to illuminate more and more. As we continue to turn it, the illuminants get brighter and brighter into the full max. As Paul was just showing us on lesson number 11, that he was teaching us the full range of our rotation to the right. Wow, I can only do it with my finger. The full rotation towards my thumb. The luminance have continued to always change. That's because we're doing an exponential growth value. I'm going to stop this, and I'm going to pull up that chart again. Showing here. Oh, wow, I can't move that. Oh, I can move it here. Shrink this down and slide this over to the side. When we were moving our X, which is the potentiometer, our Y value was exponentializingly increasing. And it was continuously increasing as we climbed higher and higher to 65,535. That's why our luminance continued to always continue to increase. To our eyes, it would always continue to grow. Actually, if you zoom this chart farther and farther towards the top, it does not look like it's moving very much, but it is, because our X value is growing each time we turn the knob to the left. It is illuminating, increasing. I hope I explained that as good as I could. I know Paul did a really good job, and he asked in the homework assignment for us to explain it, and he challenged me with lesson number 10 in the comments to try it out and to get a better understanding of it. Here you go, Paul. I've tried it, and I think I got a good understanding of it, and I could see where this would be a great value to use more often in a lot of my other challenging problems that you're going to give us later on here. Drop a line of a comment or a question, and I'll do my best to try to answer any questions that you leave. Once again, stay safe out there. Until next time.